Hello, my dear students. Welcome back to the St. Joseph Composite Few College, Bijapur. I'm chemistry faculty, and today I'm just extending a little information regarding the okay, you can say that that's covalent bond formation, and that is explained by the Cosell and Lewis. Okay. Now, what do we know that Cosell and Lewis strictly believe in the octet rule, and octet rule is very generalized rule. Okay, let's see an example where how the covalent molecule is formed. Okay, and how their octet is satisfied there. Now just assume that I have just let me write first the covalent bonding. Covalent bonding. Okay, so this is a covalent. This is all about the covalent bonding we are discussing. Now the Cosell and Lewis believed that every atom have tendency to get octet in their outermost shell by losing electron or gaining electron, and there is one more way there, that is by sharing of electrons. And here the octet is gained by sharing of electrons. This is important for us, by sharing of electrons. Sharing of electrons. There the electrons are shared. Now take an example. Assume that I have the atom F, fluorine, and this fluorine atom having 7 electrons in their outermost shell. And let me represent those 7 electrons here. 1, 2, 3, 4, 5, 6, and 7 electrons. Now there are total 7 electrons, are there? Let me take one more fluorine atom here, fluorine. Now again, let me write the 6 electrons around that. This is 1, 2, 3, 4, 5, 6, and 7 electrons. Now there are 7 electrons are there in each atom of fluorine. It requires still 1 electron to complete their octet. And for that, what it do, this fluorine shares its 1 electron with another fluorine. Let me show that half arrow. Another fluorine atom shares its 1 electron to the another fluorine atom. This is sharing of electron takes place. Now we get here these 2 fluorine atoms shares 2 electrons between them. These are the shared electrons, just writing. And other electrons, they are not shared. I represent as it is. There is no change. 6 electrons are left now. 1 electron is shared. Okay. Now I'm going to draw a circle around this. You can say that fluorine. Okay. So this is the circle belongs to this fluorine, and this is another circle I'm just drawing for the another fluorine here. Now in this fluorine, you can notice that there are total number of electrons here. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Okay. Now in the same way, in this circle we have total 8 number of electrons. Okay. Now these electrons which are shared between the 2 fluorine atoms, they are called a shared pair of electrons. Shared pairs of electrons. Shared pair of electrons. Now these shared pair of electrons belongs to both the atoms, and these are belongs to let me write this, belongs to both the atoms. Belongs to both atoms. It belongs to both the atoms. Now this is how the fluorine molecule is formed, and let me write the bonding in that. The fluorine to fluorine, there is a single bond is there, because in order to gain 8 electron, it shared only 1 electron. Okay, the 1 electron means for one bond 2 electrons are required. 2 electrons are required. Okay, let's have some more examples here. Okay, let's see how you can say that the nitrogen molecule is formed. The formation of nitrogen molecule. Formation of nitrogen molecule, that is N2 molecule. Okay, this is N2 molecule. We'll try this. Okay, so first we have to draw the nitrogen molecule here. This is nitrogen. So let's have here nitrogen is here. This is nitrogen. Okay, and there is one more nitrogen we have to write here. Here is one nitrogen. There are total 2 nitrogens are there. And now I have to write here the electrons or valence electrons in the nitrogen. And we know that the nitrogen electronic configuration we can write here. That is 1s2, 2s2, 2p, 3. You can see that 2s and 2p belongs to the outermost shell, and total they contain here 5 electrons in their outermost shell. And let me represent those 5 electrons here. This is 1, 2, 3, 4, 5 electrons. Again the same thing, 1, 2, 3, 4, 5 electrons. Now you can notice that around the nitrogen there are 5 electrons are there. To gain octet, it need 3 electrons. Let me write this point here. To gain octet, nitrogen requires how many? 3 electrons. 3 electrons are required, and because of that reason we can make a statement here: each nitrogen share total of 3 electrons, share 3 electrons, okay, in order to gain the octet. So therefore there is this electron is shared, again this electron is shared here, the same way this electron is shared, this electron is also shared, this electron is also shared, and this electron is shared here. And therefore let me write here nitrogen, and there are total number of 3 electrons are shared by this nitrogen, and again 3 electrons shared by another nitrogen. But thing is that there is still 2 electrons are remained on the nitrogen, and you can call them as the unshared electrons. Now let me draw a circle around the nitrogen. This is a circle around the nitrogen, and here is one circle that is included here, the shared pair of electrons. Now you can notice that in this nitrogen total how many electrons are there. You can notice the number of electrons here are 8 electrons are there. So how it is 1 2 3 4 5 6 7 8 electrons. Now 6 plus 2, again here also we have 8 electrons. Now whatever the shared electrons are there, you just here 3 pairs of electrons are shared. Let me write that the total of 3 pair of electrons are shared between you can say that between the nitrogen atoms. So this is all about the formation of nitrogen. We'll see one more example and then we close the discussion, students. Another discussion, let me take another page. Okay, now we're going to discuss the formation of the oxygen molecule. Formation of O2 molecule. Okay, this is also very simple, the formation of O2 molecule, and here we need 2 oxygen atoms, and known thing about oxygen atom is having an electronic configuration that is 1s2. Okay, oxygen atoms electron configuration that is 1s2, 2s2, then 2p, 4 we have, total 2 plus 4, we have 6 valence electrons. 6 valence electrons are present in our oxygen. This is the important thing we have to conclude first. Now let me draw here 2 oxygen atoms, and after that I have to write the dots, that is valence electrons. Let me write here 1 2 3 4 5 6 electrons on here. Here also 1 2 3 4 5 6 electrons. Total there are 6 electrons around the oxygen. Okay, after that, so you can notice that oxygen having already 6 electrons, it needed 2 electrons to get octet. So that point we have to write here first, that is oxygen required 2 electrons in order, that is in order or to get a octet, in order to get octet, and 2 electrons are required, and the same number of electrons are shared here. So therefore let me write the same point. Therefore next point, therefore 2 electrons are shared by each oxygen atom. So therefore let me write here this electron is shared. The first, there are 2 electrons, out of that you can share any 2 electrons here. These 2 electrons are shared. Okay, this is shared and this is also shared. Now this is also shared here, and this electron is also shared, and by that we can write here oxygen. Okay, let me remove this. There is oxygen and here is oxygen. Between the oxygen there are total 4 electrons are there, which are shared electrons, 2 by each, and remaining 2 electrons are there on the 2 pairs on the oxygen. So let me write those 4 electrons, and then I have to draw a circle here, and this is one circle. It not looks like a circle, just imagine it's a circle. That you just count here number of electrons around this oxygen. These are 2 electrons, 4, and these 4, and total 8 electrons are there. 8 electrons, and the other oxygen also shows the same thing, that is 8 electrons. Now there are total number of electrons which are shared between the 2 oxygens are 4, means there are 2 pair of electrons are shared. That is 2 pairs. The pairs of electrons are shared between oxygen atoms, and therefore there are 2 pairs are shared for each pair, one bond is formed. Therefore, oxygen to oxygen, there is a double bond is present. Double bond. Double bond. Okay, this is all about the covalent bond formation. This is the very basic concepts we are discussing in the bridge course. Thank you for watching this video, students.